Hello everybody, welcome back to learning the IGCSE curriculum with Omar. Today's video is going to be about permutations as well as arrangements. Okay, so essentially permutations and arrangements is all about counting the number of ways you can arrange or order a set of items. This concept here is quite fundamental in understanding how probability works, and once you get the hang of it, I promise you it is actually very fun. So let's get started. Okay, let's start with permutations first. Permutations is basically the number of ways you can arrange n objects in a specific order. Now, the key here is to remember that the order always matters. Now, what does that mean? It basically means that, let's say for example, you have to enter a password, okay? Maybe you want to log into your email or something and it's asking for your password, right? And it gives you a hint of the digits that are being used in the password. Let's say the hint is something like just a random array of digits. We could say 4986, right? Now, when you enter the password, obviously you're not just gonna see the hint and be like, oh, that password is 4986. Let me just write 4986 and that should be the password, right? No, if you write this, it's most likely going to be wrong because the order was wrong. You're going to have to keep trying, entering different arrangements of these digits to get the right password. This is an example where the order does matter. Just like that, the order always matters in permutation. Another thing you want to remember is that if you ever want to find the number of permutations of n number of objects, the answer is always going to be n factorial. Now let's discuss what n factorial is. The term factorial is normally denoted by the exclamation mark, or it is also denoted sometimes in some textbooks by this bracket here. So the number, let's say for example 4 factorial, it could be looking like this, or it also could look like this. The factorial basically means it is a series of multiplying numbers in which each number is descending by 1. So let's say if we have 4 factorial, all this means is that we're gonna multiply all the numbers starting from 4 down until the number 1. So it's basically going to look like 4 times 3 times 2 times 1. So the answer to that is 4 3s are 12, 12 2s are 24, 24 times 1 is 24. So 4 factorial is 24. Just like that, let's say we wanted to use the example of 5 factorial, right? If we do 5 factorial, it's going to look like 5 times 4 times 3 times 2 times 1. So the answer to that is 5 4s are 20, 20 times 3 is 60, 60 times 2 is 120. So 5 factorial is 120. Okay, the question here asks us to solve 5 factorial over 2 factorial. Now, the way you're going to counter this question is first simplify everything you have. 5 factorial over 2 factorial, all it actually is 5 times 4 times 3 times 2 times 1 over 2 times 1, correct? Now, as you can see here, we have common terms in the numerator and also the denominator, which is 2 times 1. So what you can do is cancel these two, and then you're gonna be left with 5 times 4 times 3, which is equal to 5 4s are 20, 23s are 60. So 5 factorial over 2 factorial is equal to 60. There is a simpler way to solve these questions, and that is when you have, let's say, a question like 12 factorial over 8 factorial. Now, in this case, writing all the numbers 12 times 10 times 8, 7, 6, and then again 8 times 7 times 6 times 5 times 4 is going to be a very long process, correct? So what you can do in this case is actually you don't need to write the whole thing. All you can do is you can start writing 12 times 11 times 10 times 9, and then as you can see here, once we reach 8, you can just make the 8 a factorial, because you know 8 factorial is still going to continue to be 8 times 7 times 6 till the number 1. So you can end it at 8 factorial, and then since the question is over 8 factorial, you can cancel the 8 factorials. So you're going to be left with the answer here. Now I don't have a calculator with me, so I can't calculate what that answer is, but yes, that is a simpler way to solve questions like this. Let's look at another example. Solve n factorial over n minus 3 whole factorial. Now looking at this question, you may think, whoa, that was a big jump. It went from that previous question to whatever this is. But don't worry, this is still a very simple question. It just follows the same formula, it just has variables in it this time. So what you want to do is look at the question and analyze it. We have n factorial and n minus 3 factorial. So the denominator here, all it means is that it is this, but minus 3 digits below. So if this was, let's say, 8 factorial, all this would be 8 minus 3 is what? Is going to be 5 factorial, correct? So it's the same format as the previous question, except we don't know what the number in question is. We just have a variable. So if you want to solve it in terms of this and ignore whatever this is, what you're going to do is start with n factorial, and you're going to write n times n minus 1 bracket times n minus 2 times n minus 3. Now once you reach n minus 3, you're going to make that a factorial, and since this question is over n minus 3 factorial, you can cancel these terms. So you're going to be left with the final answer as n bracket n minus 1 bracket n minus 2. So this is going to be your final answer. You can obviously simplify it further, but that is going to be your final answer. The question here asks to find the number of permutations of the word diary. Now, first things first, what you want to do is look at the word given, and what you're going to do is count the number of letters it has, and then you're going to make the factorial of that number. So in the word here, we have diary, we have 1, 2, 3, 4, 5 letters, correct? So that means the number of permutations of the word diary, including all letters, is going to be 5 factorial, which is equal to 120. So that means there are 120 different number of arrangements you can make with the letters in this word. In permutations, there is another case where you're going to have to choose x number of objects from n number of objects. What does that mean? It basically means is when you have, let's say for example, the letters A, B, C, D, E, right? We have 5 letters here. Now if the question asks you choose 3 numbers from this arrangement and then find the number of permutations of those 3 letters. This basically means is that you want to choose 3 letters from the 5 letters we have, and then find the number of permutations, the number of ways you can arrange those 3 letters within this word. So that means 2 letters are going to be fixed in their position, and then the other 3 are going to be jumbled. So let's look at an example. This question here asks us to find the number of 5-letter permutations from the word Singapore. Now it says to find the number of permutations from the word Singapore, which has 1, 2, 3, 4, 5, 6, 7, 8, 9 letters, correct? But it's not asking us to find the permutation of all the letters, not the entire word. It's only saying to find the permutations of 5 letters. So what you're going to do is you're going to take 5 letters, 5 designated letters from the 9 letters we have here, and then find the permutations of those. So for that, you're going to have to follow the formula that goes by n p r equals to n factorial over bracket n minus r whole factorial. Now, what does this formula actually mean? To decode this formula, we're going to look at the letters. N is for the total number of objects you have. In this case, it is 9. And then P just stands for permutations. It doesn't have any value. R stands for the letters that you're going to be arranging. So in this case, it is 5 letters. So that means for this question, it is going to be equal to 9p5 equals to 9 factorial over 9 minus 5 is what? It's 4 factorial. So 4 factorial. So 9 factorial over 4 factorial is the number of 5-letter permutations that you can make from the word Singapore. Okay guys, so those were the fundamental concepts of permutations, arrangements, as well as factorials. If you guys have any doubts or further concerns regarding this topic, please feel free to let me know in the comment section below. Yeah, like and subscribe, and until next time.